Ask us what in fact is the inverse of the problem, and we'll do that. And there isn't a, take the composite function, then we can just go ahead and do just as I'm doing here, erasing this, reverse the x and the y, and then proceed to solve for y. Number 41 says to give the inverse. Give the inverse of f of x equals to 4 minus x over 9, right there. Give the inverse of that. As I said, to find the inverse, rather straightforward. Just interchange the x and the y. Remember, f of x is y, so I'm going to call that x. And that should equal to 4 minus interchanging the x and the y. That's going to be y and all over 9. And then we're going to solve that for y. We're going to multiply both sides by 9. Multiplying both sides by 9, 9x minus 4 will equal to, be careful now, and how many times have I said, don't forget the minus sign. You need a minus sign in there, right? That minus sign doesn't go away. This is not a magic class. It doesn't disappear. It's going to stay. After that, we'll proceed to maybe go ahead and take the opposite of everything. How about saying y is equal to negative 9x plus 4, and you could put the positive 4 out front if you want. It doesn't make any difference. I think the author might do that, but this looks good enough. We're going to say y is equal to 4 minus 9x, or negative 9x plus 4. Just one change if you would. Change this y to f inverse of x, a little minus sign there, and that should be our answer, negative 9x plus 4. And that's the inverse of what we talked about here. That's the inverse above of 4 minus x over 9. One other example here, the last one I think for us for this particular page, and that's going to be number 48. Do follow your syllabus, please, and do the other problems. These should be nice examples for those. I'm trying to choose especially the even ones, if there are even ones there, so that you can do the odd ones and check those. 48 is s of x is equal to 2 over x minus 3. And again, we'll interchange the x and the y. We're going to call this, instead of s of x, instead of y, we'll call that x. And that's equal to 2 over y minus 3. Those are x being changed to y minus 3. I would normally just interchange these two. This is a proportion, and you can interchange the extremes. I think I've shown you that before. Many people don't like that, so I'm just going to multiply both sides by y minus 3. I'm going to multiply the left side by y minus 3 and the right side. Notice on the right side, without having to write it, if I multiply by y minus 3, those will go. And basically what's going to be left is just the 2. And over here, we'll have x, and then we're going to multiply, as I said, by y minus 3 times y minus 3. So multiply both sides by that y minus 3, and we'll be left on the left side with x, y minus 3, and the right side, the y minus 3's will go. You could distribute the x now if you want. I'll do that, but I'm really just going to divide by x myself, but it causes some problems with the fractions for some people. So I'm going to leave this as x, y, minus 3x. Don't forget our most important property, and this is where I'd wait for a while to have you tell me what it was. And you can stop the video if you want to ask yourself what it is, but you should know when you give that to both, it's called what? Distributive property, right? The most important property in math. Give that to both, and then from here you want to solve this for that red y. So how about maybe adding 3x to both sides? If you add 3x to both sides, you get xy by itself over here equals to 3x plus 2 or 2 plus 3x, either way. And the last step here will be to divide both sides by x. So dividing by x on both sides, how about y is equal to 3x plus 2 over x, dividing by x on both sides. The last thing we do would be to change that y to f inverse of x, the f and the little negative 1 up there in x. And that should be a nice answer for us. F inverse of x equals to 3x plus 2 all over x. Remember, you cannot cancel the x's here. This is a good answer. Leave it. Don't cancel the x's. And totally wrong. You cannot cancel across an x and minus. I mentioned that a long time ago. That should then complete our section there. We're going to start then on the next chapter, and the next chapter talks about exponential and logarithmic functions, and I'm going to start right in on that. Maybe use that for a minute. And we're going to look at number 10A, and this page 423, please. Page 423. And do just the ones I've asked to do, because some of these are really difficult to do without a calculator. I'm trying to give you ones to do just as samples that don't require a calculator. And that might save us a bit of time and also be a lot easier for us. Number 10 says this. It says g of x is equal to 7 to the x power. Now, it's important to understand that this is not 7x. It's 7 to the x power. And just to give you an idea of where we're going with this, obviously, if I give you something like x squared equals to 25, you can tell me x was 5. If I said 5 to the x equals 25, you should be able to tell me that x in this case is 2, because 5 to the second power should equal to 25. Well, let me just change it a bit. How about if we said instead of 5 to the second, well, we could even leave it as 5 to the second. We could do that. That's no problem. How about if we said 5 to the 7 equals to 15 instead of 25? Let's give that a try. Okay, 5 to the second is 15. What number, 5 multiplied, how many times will give you 15? Well, 5 to the 1 is 5. 5 to the 2 is 25. So it looks like 5 to the 1 point something in here, 5 to the 1 point something should equal to 15. Since 15 falls between 5 and 25, 5 to the 1 point whatever should equal to 15. I want to be a little more definite on that though. 5 to, not 1 point something, but 5 to the 1 point and give me the numbers, okay? So we're going to try to get more involved with this to find out a little more exactly, a little more precisely what that might be. That's where we're going. For right now, we're just starting out and looking at the exponents and playing with those. So for right now, we have number 10a. We have 10a as 7 to the x. And again, not 7x, but 7 to the x power. And we like to proceed to look at part A on that. Part A says, how about g to the negative 2? So what we're going to do here is very similar to what we did just a moment ago. We're going to go back here and say g. And instead of x, put a negative 2 in there. And let's see what happens for that. 7 to the negative 2. Expecting now you're going back to your rules. We've talked about exponents before. This is not new. In fact, it's nothing more than substitution. We replace the x with a negative 2 on both sides. 7 to the negative 2, you should understand what the negative does. The negative, and here's where I'd wait again. Instead, I'll proceed. You can stop the video if you like. The negative sends it to the other area. The negative is going to send it to the other area. And it's going to become 1 over 7 squared down here. It goes to the opposite area. It takes on the opposite sign. And of course, another name for that is what? 1 over 49. So our answer for 10a is 1 over 49. Important to realize this is 7 to the x power. It is not this. It is not 7x. Be careful, we're going to be doing that through the entire chapter. The next one, number 12, I ask you to try 12a also. I think you'll be working the odd ones. And again, just the A or B or whatever I'm asking you to do there. Don't go any further because these require a calculator. We're not using a calculator, so you won't be needing that. And 12a says k of x this time. K of x equals to 1/6 to the x power. Again, not 1/6 times x, but 1/6 to the x power. And we're looking for a, which is k to the negative 3 power, in fact. Okay, very basic, similar to the previous one. We're going to say this is 1 over 6 to the negative 3. We could again deal with the negative exponent first, or you could apply that 1 to the 1 times negative 3 and 6 to the 1 times negative 3 to multiply the exponents. I'd rather deal with that negative. It's going to send the items to the other area if you would, or in this case, flip the fraction I think we talked about before. And this is going to be 6 to the third here if you would. If you did it the other way, if you multiply the exponents 1 to the negative 3 and 6 to the negative 3. 1 to the negative 3 is 1. We can forget about that basically. What happens here is though, the negative 3 will shift that to the numerator there, and it becomes the same thing we have over here to the right. It'll be 6 to the third. Okay? So 6 to the third should be our answer. And if you go ahead and change 6 to the third to, I think 6 times 6 times 6, 36 times 6, I think is 216. Okay? So that should be the answer for us from number 12a, 216. So we have two examples there with the exponents, numbers 10a and 12a. We're going to take a look also at number 18, which is 1/4 to the x. But this time the author is asking us not to find out what the x to whatever is. Instead, make a picture of this, okay? We should see what an exponential curve looks like as a picture. So we'll be doing that in a minute. And it takes a little bit of effort because you have to be careful with the fractions and be careful with the exponents especially. This is an exponent section, an exponent chapter, so you want to be careful with the exponents throughout. Make sure you have big minus signs, whether it's a negative exponent there, or whether it's a positive exponent. F of x equals to 1/4 to the x power for number 18. I'd like to make a sketch of this, a bit of a graph, but not terribly accurate, but a nice sketch if we can. We usually choose some numbers, x and f of x, or x and y if you would. And we're going to choose maybe numbers between -3 and +3. Insert a -3 in place of x. This is going to do the same thing that happened back in the previous problem. The negative will basically flip the fraction, and this is going to be 4 to the third. 4 to the third power. That's about 64, I think, okay? Probably not going to draw that, but at least we'll get the number for you there. -2, let's change that to a -2. And -2, of course, but that's going to again flip the fraction, and that's going to give us 4 to the second, which should be 16. At -1, you can see what's happening here. The same idea. And that's going to be 4 to the first, or just 4. And most important, at 0. We haven't talked about that for a bit, but you should know that anything to the 0 power is... Okay, I'm waiting. I don't hear any response. I won't get a response, unfortunately, because you're not here. But you should remember that what? 4 to the 0 power should be 1. Or not intuitive at all, but anything to the 0 power except 0 is 1. So this 4 to the 0, when x is 0, we get a 1 there. And then from here, when x is 1, these are the easy ones you might say. When x is 1, then of course y is going to be 1/4. 1/4 to the 1. When x is 2, and that's not 2/4. When x is 2, remember how you find that squaring, just 1/4 times 1/4. Really simple, don't make it tough. 1/4 times 1/4 is 1/16. Just multiply straight across. 1 times 1 and 4 times 4. So this is, I should put an arrow there, it looks like